thanks for subscribing to our channel. We really appreciate you. We thank you for liking our videos and sharing them as well. For those that are yet to do so, please kindly do so. And don't forget to subscribe if you are yet to subscribe. That will help us to give you the best of our content, and you get easily notified immediately we upload any of our contents. Today we want to quickly look at a particular aspect of the science world, which is titration in chemistry, particularly for the students that are going through their Waec examination right now. Now, we want to look at titration, like I said, and titration is actually the reaction between two substances. We are trying to know where the equilibrium is going to be, what the endpoint of the reaction is going to be. So we are actually going to be using two materials or two substances, two reagents, two chemicals, as the case might be or will be. That is going to be, we'll be using an acid as well as the base to carry out our titration. Now, today we want to be using two acids, two substances. The first compound is the HCl, that is our acid, and the second is the sodium trialcarbonate, that is our base. That is what we are using for today's class, which is the titration. So these are the two materials that we are using. We are using the HCl, which is an acid, and we are using sodium trialcarbonate as our base. So we'll quickly run us through the reagents and the materials that are used for the substance. Here I have what I have my prepared solution for the acid, and here is my prepared solution for the base. These containers or glasswares, they are called volumetric flasks. Now, I have here my retort stand. This is my retort stand, and this one that I am holding here, this particular glassware, is called the burette. So it is in this burette that we have the content of the acid being put into. Also, I have this one which is called the pipette. It is actually used to measure a known volume of the base. Now we have two types of pipettes. We have the 25 ml pipette and the 20 ml pipette. For this particular titration, I will be using the 25 ml pipette. So I have here my conical flasks. I have my conical flasks, they are clean. I also have here my beakers. So I'll be adding the contents of this reagent bottle, or the volumetric flask into these beakers. So this is my B. I am adding this to it. And here I have my A. So this is my A. I am adding my A to this. Alright. So I'm going to use my A now. I will use my A to fill the burette. I will use my A to fill the burette. So that is what I want to do right now. I have my burette being filled with my A. So I have filled the burette beyond the graduated point. So I will gradually dispense the content of the burette so that the liquid in it is having its mark sitting directly on the graduated mark. So when we talk about titration, there are some errors that students fail to take note of, and these errors actually are responsible for some of the difficulties they eventually come across during the practical. Now, one of them, we call them parallax error. Parallax error. So we have different types of error. One of them is actually using the upper meniscus. When you are carrying out your practical, you should use the lower meniscus. The lower meniscus should always be on the graduated mark. So let me quickly explain that. Let's assume this is our burette or the pipette, as the case might be, and this is our mark. This is the mark or the graduated point where our liquid is going to get to. Now, when you fill your burette or your pipette with the liquid, it is always going to have something that looks like this in the middle. It is going to have a curve like this. Now, it is expected that this space here, this particular part here, is sitting directly on the mark such that you will have it looking like this. It should be looking like this. So this is actually what we refer to as the normal measurement. If you have yours looking like this is the graduated mark, and your lower meniscus is under the mark, then this is actually wrong. So one of the errors is what they are having the lower meniscus below the mark, the lower meniscus. So you should always make sure that your lower meniscus is on the mark. The lower meniscus is sitting directly on the mark. So now we can actually go with practical. Now I have filled my birette and I have graduated my birette. You should always also remove your funnel. Failure to remove your funnel from the tip of your birette probably might have your funnel dispensing more acid into the birette, and that will eventually change the volume of the content of your birette. So it is very, very important that every time you fill the birette, you should remove the funnel. So that is another parallax error. Error due to the removal of funnel. Removal of funnel. Alright, we've listed those. Now let us go to the practical proper. So I have my base here. This is my base. So I'm going to use my pipette to take a known volume. Remember that I said that this pipette is a 25 ml pipette. So I am taking a known volume of my base and I'm going to dispense it into the conical flask. So you gradually allow your tongue to go off the tip of the pipette so it can allow the liquid down into the base where you actually have the mark being graduated. So I am dispensing now into the conical flask. Now for this particular type of titration that we are doing, we have a strong acid, which is our HCl, and a weak base, which is sodium transcarbonate. A strong acid and a weak base. So that is going to inform the type of indicator that we will be using. An indicator is what helps us to mark the end point of the reaction. It helps us to identify a color change that marks the end of the reaction. So for different types of titration, like if we have a strong acid reacting with a strong base, we can use any type of indicator. Any type of indicator is fine for that type of reaction. But if it is a strong acid with a weak base like what we are having here, then we'll be requiring a methyl orange indicator. That is the type of indicator that we'll be using today. If it is a weak acid and a strong base, then we'll be needing a weak acid and a strong base. We'll be needing phenolphthalein. Phenolphthalein is going to be used as the indicator. But if it is a weak base and a weak acid, then there is no suitable indicator for that. So for this particular reaction, we are going to be using methyl orange. Now, the use of methyl orange is also very, very crucial to avoid errors. You need only 2 drops of your indicator. You don't run your indicator into the conical flask, into the content of your conical flask if you actually want to have a good reading. So we are going to start that now. So we are looking for a color change in the conical flask. So we gradually run the content of the birette into the conical flask and we'll be looking out for a color change. Remember that when we started the reaction, it was giving us a bright yellow color. So we'll do that, we continue until we notice a change in the color of the liquid in the conical flask. So the moment you notice that there is a color change that you are seeing and it is disappearing, it is telling you that you are gradually getting to the end point of the reaction, so you should carefully dispense your chemical into it. So the moment you notice that there is a color change that is disappearing, you gradually do your dispensation. So my color change is appearing and disappearing, telling me that I am close to the end point. So yes, now I have gotten to the end point of the reaction. Now this is somewhat pink in color. Now if I check this, it is giving me a graduation of, I have 24.8. So yes, let me talk about this. We also have a reading on a table. We usually have a table that we must always be careful how we fix. Here I am going to have my final reading. Final reading in CMQ. And here I will be having initial be having my average titration value. That is what I'll be having here, because you'll be having a calculation at the end of it. So here I'll be having my rough, here I'm having my first, here I'm having my second, and here I'm having my third. So that is what we have for. Because my burette is a 50 mils pipette, my burette is a 50 milliliter burette. I am going to be having the gradation starting from 0. So here my initial reading is going to be 0.00. And what I just finished dispensing is taking it to 24.8. That tells us that if you subtract your initial from your final reading, you'll be having 24.8. That tells you that, now, look up, this is rough titration value. If this is rough titration value, that means you can actually achieve your aim before you get to this point of the rough titration value. So we're going to try another titration and see if we can achieve our aim, a color change before we get to this particular point. And remember, for titration we need concordant readings that are not different with more than 0.2 a difference of 0.2. So let us take another reading now. So I'm taking my base from my base is from the beaker for B, and I'm dispensing in this clean conical flask. So I want to show us between this color and the one we'll be getting now, if it is going to be possible for us to achieve our aim before we actually get to that color change of the 24.8. We can achieve our aim before we get to 24.8, which is the reading for our rough. So I put my base in there. I'm adding my indicator now, 2 drops of indicator, and then I shake very well. So if you look at it now, it is giving us a light yellow color or a golden yellow color, and so now I can start dispensing. Okay, I have not added. Yes, it is important that you feel, but I could have continued reading from where I stopped, but let me feel the content of my burette again to take it back to the 0 mark. To make calculation easy, it is advisable that you fill it back to the 0 mark. Yes, so I have done that, and you always remember to remove your funnel. So I am dispensing gradually into it now. So the moment I notice that it is getting to 24, I can start dispensing in bits. Yes, I am close now, so I can start dispensing in bits. We need a color change out of the yellow color. Alright, so this is the color change out of yellow. It's giving us the color change that we require, but let's, for the sake of clarity, let us just dispense. Okay, so this is where we are actually going to. You can see it now. So it is no longer the yellow color that it was. So at this point, it's giving us 24.4. That is what we have here, 24.0.00, and here we have 24.4. So let us take 2 more readings. Let's take 2 more readings. So let me dispense this one. I'm dispensing this. So I have my wash bottle here. Let me quickly rinse this chemical flask. I'm taking another measurement of my base. Alright, so I have this done. Alright, so this is the content of the base that I'll be using. So let me quickly, while that one is dispensing into the conical calculate it. Right. Okay. My acid is right where I want it to be. So this one has finished dispensing. So let me add the next step is adding the indicator. So I'm adding 2 drops of the indicator now. I've added 2 drops of the indicator, so I shake to stir, after which I can go for my reaction. Now if you look at the 2 materials in the conical flask, you notice that there is a color change. This one is darker in complexion, but deeper than this one. So let us see what we can have for this one. So I start dispensing into this one as well. So I'm running my acid into it because I know where I am actually going to, or is this the area that I'm actually going to. So I am close by now, so I can start dropping bits. I can start dropping my content in bits. So adding my content in bits, this is what I have achieved. I have achieved this. So this is slightly different from this, but it's clearer. Yes, so I will use this one now as my next reading. So this one is giving me a value of 2.6. So it's giving me a value of 24.60. Okay, let's take another reading. Let me dispense this one. Let's take another reading. Let's take another reading, the last reading now. So you'll be able to have options for picking your average tetra value. That is why we're taking after the rough, we're taking multiple readings. So we're dispensing, we're gradually checking now. We've gotten what we want from the base, so we're going to dispense. Alright, if you look at my base now, you notice that there's something going up in the pipette. That is going to make the reading wrong. So I have to dispel that. If you check, it has changed the lower meniscus, so I have to change that too. So let's graduate now. Alright, so I'm dispensing here. So while this one is dispensing, let me quickly top up the content of my burette once more. So I have added the content of my burette, and I have this there. So I am removing my pipette now, and I'm going to add indicator, which is methyl orange. I'm adding 2 drops of the methyl orange. So I shake very well, and then I can start my titration. So I'm running my content into it now. I'm going to somewhere that gives me a color change. The earliest color change is what I am looking for. Okay, so this is what we are actually looking out for. Well, it is still having some yellow in it, so let us add a bit to it. Alright, so this is what we are actually looking out for. So if you look at these two, they somewhat look alike. So that is where our titration will be ending. So let us see, this one is telling us that it's 24.6 again. So we have 24.6. So that tells us that we are having here, we are having 24.4. Here we are having 24.60. Here we are having 24.60. And because I told us earlier on that we should have concordant readings with a margin of not more than 0.2. We have our first reading which is 2.4, our second reading and our third reading they are 24.4 for the first one, then second and third we have 24.6. So the three of them they are not different with more than 0.2, so we can actually use the three of them for our reading. So we have to calculate what we refer to as the average tetra value. Okay, sorry, I wrote average tetra value here. This is supposed to be the tetra value. So let us now calculate the average tetra value. Average tetra value. So we have 24.60 plus, 24.40, then 24.60 plus 24.60 divided by 3. So 24.40, 24.60, 26.4.60 is going to give us a total of, we have 72 plus that's going to be 73.60. So divided by 3. That is what we so we should be having 73 point, let's say 20. That should be average tetra value. Should be having something around this value. 1, 2, 3, 72, 73, then yes. So we should be having something that looks like this. 24 rather. 24 points, 24 points, that's 5 or thereabouts. So that is what we should be having for our, okay, let's just quickly do this properly. We have 160, so we should be having 24 rather. Okay, so we should be having something in this range. So that is what we'll be using for our average tetra value. So that is going to be the volume of acid that is used for a known concentration of base and a known volume of base. So our VA now is going to be 24.55 cm3. We should not forget to add that. And then we have our VB, which is known also to be, okay, then this one is going to be 25 mils. So that is what we have for that. We'll use this value to quickly carry out a couple of questions to aid your understanding of the topic. Please don't forget to like our page, to share our content, as well as subscribing to our channel. We really appreciate it. Thank you very much.